So in this video, we're going to talk in a bit more detail about the concept of indifference curves. We're going to introduce some very important ideas that we need if we're going to fully understand indifference curves, and we're going to practice with some indifference curve questions. So firstly, the key concept here, diminishing marginal utility. It says that as you consume additional units of x, the gain in utility from each additional unit will tend to diminish as the total amount of x consumed rises. That sounds very complicated, but if you look at a graph, you can actually see it's very simple. So on the x-axis, we have the consumption of good x. Let's say x is going to be ice cream. And we can see that as we consume additional units of ice cream up to x1, we will get an increase in our total utility. So the additional utility from one more unit of ice cream, we call that the marginal utility. And we can see here the marginal utility of x is positive for this range of values, right? So we have increasing marginal utility, but clearly the gain from each additional unit of x is diminishing. So here, the first ice cream gives us this amount of utility. The second ice cream increases our total utility to this amount, but the gain from the second ice cream itself is only this amount. So the marginal utility of the second ice cream is clearly less than the marginal utility of the first ice cream. We can do the same for the third ice cream. We can see that the total utility increases by even less, relatively speaking. Okay, so then our diminishing marginal utility is going to give us the utility function that looks like this. And if we take this to its logical extreme, it could well be the case that the marginal utility becomes negative. So imagine here we have 15 ice creams. So if a consumer was to consume 15 ice creams in quick succession, they might become ill, they might start to really suffer as a result, and they might start to experience negative utility from any additional units of ice cream. So they would be never willing to say, they would never be willing to consume an additional unit of ice cream beyond 15 units of ice cream. Okay? So this is the idea of diminishing marginal utility. This is going to be important for understanding the gradient of the indifference curve. So let's draw an indifference curve here. Let's say this is point A, this is point B. And for argument's sake, we have 3 units of x, we have some unknown quantity of y at point A, we have 4 units of x at point B, some unknown quantity of y called y2. So the gradient of the indifference curve is basically the slope of this line. So we can do some quick and easy maths here to understand what the slope is going to be. Well, firstly, it's going to be negative, isn't it? If you give me 1 more unit of x, you can take away some amount of y, and I will remain indifferent. The question is, how much y can you take away? Well, that is the marginal rate of substitution. So imagine here that I was to say the following. I know that the utility at point A is equal to the utility at point B. So when I move from A to B, the change in utility is 0. Well, I can then say, because I have gained 1 unit of x, it's equal to the marginal utility from x minus the marginal utility from y multiplied by the change in y. So you've lost some y. For each unit of y that you lose, you're losing the marginal utility of y. So then, what I can do is I can rearrange this, can't I? And I can write that delta y divided by delta x, because delta x is just 1, is equal to negative marginal utility of x divided by marginal utility of y. So that is the formula for the marginal rate of substitution. The marginal rate of substitution is negative marginal utility of x divided by marginal utility of y. Okay? So this is very, very important. It's going to give us the fact that the indifference curve is convex to the origin. So if we were operating way down here, we have lots of x and a small amount of y. So call it point C. If we have lots of x and a small amount of y, if somebody offered you an additional unit of x, you might accept it, but only be willing to give up a very small amount of y in return. So that would mean, of course, that the value here, the marginal utility of x, is going to be relatively small. And this would be relatively large, giving a shallow gradient. Of course, intuitively it makes perfect sense. When you have lots of x and a small amount of y, additional units of x don't have that much value, and losing y is quite a serious problem. So then your gradient is going to be very shallow. Reverse it, if we're at point A, we have a small amount of x, a relatively large amount of y. If somebody offers you an additional unit of x, you might be willing to give up a relatively large amount of y to gain that additional unit of x. The marginal utility of x will be large, the marginal utility of y will be small, the gradient then will be relatively large in absolute terms. So this is where the gradient of the indifference curve comes from. Okay, so then let's just look at a quick and easy multiple choice question on indifference curves, and we can show something about the properties of indifference curves. So firstly here, you've got two indifference curves, indifference curve 1, indifference curve 2. What can be concluded if the consumer moves from Q to R? Well, R is on a higher indifference curve than Q. What does that mean? Well, let's say we have this point here, F. We know that F must be preferred to Q because F has more of good X and the same amount of good Y. But F is then on the same indifference curve as R. So therefore, R must be preferred to Q. Right? R gives you more utility than Q. Having more utility is surely good. And pursuing something which is good is surely rational. So moving from Q to R is a rational thing to do based on our assumptions of consumers as utility maximizers. So that is the answer to this one. Another thing that we often look at with indifference curves is we think about this situation or this possible situation. We imagine two indifference curves intersect. So here you've got indifference curve 1, indifference curve 2. Let's have some points. A, B, C. So, can indifference curves intersect? Well, if these two indifference curves intersect, we can say the following. We can say that A gives the same utility as C, because they're on the same indifference curve, but B must give more utility than A because B has more of X and the same amount of Y. So that is equivalent to saying B is preferred to A because C and B are on the same indifference curve, and A and C are on the same indifference curve, it must also be the case that the consumer is indifferent between B and A. But if you're indifferent between B and A, then B is not preferred to A, right? You don't prefer either. So here, B is not preferred to A. So if the two indifference curves cross, we can say that B is preferred to A and B is not preferred to A. But that's very clearly a contradiction. So you know that if you make an assumption and that assumption leads to a contradiction, then you must reject this assumption. So here, it cannot be the case that the indifference curves cross. It doesn't fit with what we think about preferences. So indifference curves cannot intersect. Okay, so this is a quick overview of these